So take a minute to jot down this problem and the information from Target and Tops. And what we're trying to figure out is, do Target or Tops bags hold more? They're plastic bags. Do they hold more weight? Now, a couple ways that we can go about doing this. Our goal is really to find out what's the average that Target is going, because it looks like they're going at a pretty good average. So take these 5 items for Target and average them together. But I would make a spreadsheet of this to figure it out. And copy down the standard deviation from that table. Since we're doing a sample, we always do the S of X. We don't do the sigma, the baby sigma. Let's do the same thing for Tops. Now we got to figure out what we're testing here. We need an HO and an HA. Let's figure out what we're testing. We want to see if one holds more than the other. So our HO is really like, where would they break even? If the real mean of Target brand bags equaled the real mean of Tops brand bags. And if this works out and we get a very large P number, or larger than 0.05, we'll say that, yeah, we think that they hold the same. You can pick pretty much either way, greater than or less than. Keep in mind which one you're going to be doing. I'm thinking, judging by the looks of this table, I'm thinking Target is greater than Tops on average. You could do it the other way around, less than. It's up to you. In the end, we're going to end up with 2 numbers that are sum to get 1 anyways. The probability of one is kind of the opposite of the probability of the other. So to me, I'm thinking that Target looks like it's holding more, but you could do the other way around if you wanted to test this. Now, another thing that I'm going to do over here is I'm going to rewrite it over here. And what you'll see in the book is something like this. And it might even be in your calculator like this. If you were to try to do, this is going to be a t-test, a 2-sample t-test. It might have something like this, where the mean of Target minus the mean of Tops is equal to 0. And you're trying to say, okay, Target take away Tops. If they equal 0, then they're pretty much equal to each other. And then you might get the same type of thing on the other side. Mean of Target minus the mean of Tops probably is going to be bigger than 0 if they're doing better. Target would outperform Tops, and when you subtract the means, you should be bigger than 0 for the one that I'm kind of looking at. Now, the goal is then we need a difference, just like the title says. We're trying to calculate the difference of everything, what the true difference is. So for a minute now, I've got to try to figure out what the sample difference is. Target minus Tops. Now, back from chapter 5, I think it was, just like in the last video, you could actually take the 2 means and subtract them, and you would get 3,005. This is actually the mean difference between the 2. Now, what we have been doing also is making like another chart of our table and saying, okay, this is where we put the difference in, right over here, and subtract and get an answer, subtract, get an answer, subtract, get an answer, and work it out like that and put that in a spreadsheet and find the mean. That would give you the same answer, 3,591.8. It would give you the same answer. The difference between this is you got to be careful because we didn't actually have to test both the equal amount of times. We might have tested target 10 times and tops 8 times. It's just by coincidence that we tested them each 5 times. So once you do a difference of numbers where they're not the exact same amount of in each sample, then it doesn't work out well when you're doing this subtraction, and it might screw your data. And also, the standard deviation doesn't work at all when you do it like this, because you're not taking into account that you tested target 5 times and you tested tops 5 times. You can't just use the standard deviation in these, because the standard deviation of the difference, or when we're putting it into this difference, you actually have to do, to find the standard deviation, you have to do standard deviation of target divided by the number of times you tried the bag, the amount of trials you did. And the same thing with tops, standard deviation of tops divided by the amount of times you tried tops. They don't have to be the same number. So sometimes people will put n of target and n of tops, and we can go crazy with all these sub letters that we could write in. Now, this would give you your standard deviation for target with the sample included, and tops with the sample included. But you have to remember from chapter 5 or 6 when we did this, when we are combining or when we're subtracting, we can do the same thing with the means of whatever we're doing. If we're combining, we add the means. If we're subtracting, we can subtract the means. But I don't know if you remember this formula where we had like A minus B is equal to A plus B. It was the same thing, and a few people thought it was a typo, whether we were adding or whether we were subtracting data. We still had the same type of formula over here. We actually have to square both standard deviations, sum them together, and then we could get the sample target minus tops standard deviation that we should use in the problem, but not really, because it gives us the variance of that. It gives us the squared value of that. And to get rid of the squared value and get just the standard deviation, we'd have to square root both sides. And we end up with this crazy formula. When you simplify everything within there and do what you can for like squaring within here, when you square both sides, you end up with target minus tops. On this side, you end up with the standard deviation of target squared, and you were supposed to square the square root of n. So you end up with plain old n down here, plus standard deviation of tops squared. Square root of n squared would give you just n of tops. This formula is on your formula sheet. It says difference of sample means, except it's written like this, with the population means in there, and it says like this, 1 and 1, 2 and 2. And it says difference of sample means right next to it, difference. And notice it's still a plus in between there though, difference of sample means. So I wanted to show you the origin of it, not saying that you have to actually memorize it, but that's where it's all developing from. Same thing as we were doing as all of our significance tests, we were saying the standardized test statistic equals the statistic minus the parameter over the standard deviation of the statistic. So for mean, we're going to use a T. Now, for the statistic, we're saying, for this sample, what is my sample mean difference? So I've got to use this information over here, 3591.8. What is my HO? What do I expect to get? This is my difference of my means of target and tops. This is my difference that I expect to get, target minus tops. This is kind of why I had you rearrange this a little bit over here. We've got that we expect for it to get 0. Standard deviation of the statistic. We did all this substituting, but we didn't actually calculate it. That's what we have to use down here, 1079.9. Otherwise, it's done exactly the same way all of your other ones were done. We want to still divide. And we've been always pretty much using like the hundredths place. So it's like 3.3, I would round it to 3.3. And we need to find the degrees of freedom. And like I said, each one doesn't have to be the same. So technically we could have done a sample of 10 times at target and only 5 bags at tops. We didn't actually have to have the same amount. You want to take the smaller number and subtract 1, the smaller n, and subtract 1. Our n's are tied, so 5 minus 1 is 4. We're going to look for the degrees of freedom of 4. It's more conservative that way, which is better than to give more radical data, okay? So look under the degrees of freedom of 4 on the table, and we are looking for 3.33. So you want to see what between two numbers do you get 3.33. I'm getting 0.02 and 0.01.